Mr. Shayan. Thank you for joining today. I'm Rabia, a public interviewer from ideaXme Public Playlist, an environmental engineering senior at the University of Engineering and Technology, Lahore. Today, I'm privileged to be here with Engineer Shayan Sohail Sarwar, a chemical engineer and innovator, and a chief technology officer of PakVitae, a company working towards solving world water problems for low-income societies by developing the world's first intrinsically antimicrobial membranes for water filtration. In 2018, PakVitae was a regional winner for Pearl Prize and obtained a funding of $18 million. This young team of innovators also made the Forbes 30 under 30 Asia 2020 list. Give a brief introduction of yourself.
Hello, Rabia. First of all, thank you so much for inviting me over and giving me an opportunity to speak about myself and my technology that I'm working on. I am a chemical engineer and I have been working on membrane sciences since last 7 years. So I'm working on development of hollow fiber membranes since 2013, and I've been working on incorporation of antimicrobial characteristics in hollow fiber membranes since last 4 years. All my experience and interest lies in the development of polymeric membranes, and that too in hollow fiber membranes, because membrane is a very huge field and there are numerous types of membranes, and it takes a lot of time to master just few polymers that you can use in manufacturing a membrane. As we discuss ahead, you'll realize that how difficult it is to become specialist in more than one or two or three types of polymers when you're working in a membrane field. And also it is very difficult to specialize in more than one configuration if you're manufacturing industrial grade of membrane.
You're working with membranes. So I would like to ask that how engineering in particular helped you in bringing water innovation, like innovation in water sector, and hence in developing the foundation of PakVitae.
Membrane development is another field in itself. But as a chemical engineer, I found that the utilization of chemical engineering subjects is very important in the development of membrane. For example, we start membrane design by analyzing its phase diagrams. For example, we see that if we are going to mix certain polymers in a solvent, then what kind of a phase diagram are we going to achieve in order to analyze that what are the points of polymerization and what are the points of depolymerization of that solution. So this is the this is the start of chemical engineering. Then when you are manufacturing, when you are designing the process of a membrane, the heat transfer subject, mass transfer, thermodynamics, all of these are very important subjects, and especially fluid flow, fluid dynamics that you use in membrane design. So if I talk about hollow fiber membrane, in order to give a shape to any polymer, you have two methods. You can either heat that polymer to melt it and then give it a shape in the liquid form. But we know that energy intensive processes are very expensive. So in order to manufacture a membrane through a cheap process, you need to dissolve the polymer in a solvent and then you can give it a different shape. So it starts by dissolving this polymer into this solvent. Now, when we extract the solvent, the heat transfer is maintained in order to maintain the speed of polymerization, because by controlling this mass transfer and heat transfer, you can control the morphology of membrane. If you are manufacturing your membrane very fastly, you will have a dense sponge-like structure. If you're doing it slowly, then you will have a different kind of structure. The pore size will be different. So it depends on how you are going to utilize these mass transfer and heat transfer operations. Then we add different buffer polymers, you can call them. We add these different additives in this solvent, and then this solution, it goes into different tanks of different types of solutions that can dissolve different polymers at a time. So for example, I have 3 polymers in one solution. In my mixture, it is called a dope solution. My base polymer is going to determine the shape and morphology of my membrane. The other additive polymers are there to give it a structure. Now, in order to explain to you in a very easy way, assume that you have a liquid that has multiple components in it. It goes into another solvent, let's say water, and it starts to extract that solvent from the dope solution, and it will leave a polymeric structure behind. It will start to leave a polymeric structure behind. Then you start to extract those additive polymers one by one from this main body, and this is how you get that hollow structure at the end, because all the polymers that you extract at later stages, they leave behind open pores. Okay, and this is how you create the porosity. This is how you give different shape to your membrane. This is how you control the mass transfer rates. So a membrane manufacturing process is highly dependent on all the subjects that are the basics of chemical engineering.
So, as you're working like in membranes, tell us like about a few challenges in membrane filtration that you face.
The biggest challenge is that when you remove all these contaminants or undesired components from your stream in order to achieve a desired product, these contaminants, they do not disappear. They start to stick with the wall of the membrane, and they start to deposit on it. So deposition of contaminant is one of the biggest problem in membrane sciences. Now there are many types of deposition. There is a deposition of inorganic matter, there is deposition of organic matter, there is biofilm generation, there is scaling. So all these are very huge challenges in membrane sciences. Why? Because once you place the membrane in operation, within hours the bacteria will start to form biofilm, and within hours your flux will reduce significantly. So for the first few hours of operation, your flux will reduce significantly. It can even go as low as 30% of initial flux, and then it will stabilize and it will stay there for a longer period of time. Now, in order to have a steady state operation and in order to achieve high flux through the membrane, you utilize different chemicals in order to clean the membrane. If you're cleaning your membrane again and again, the same chemicals that are used to remove the scaling or deposition of any contaminant from the membrane, they are also damaging the membrane itself. So you are causing erosion in your membrane and disintegration of your membrane. And if you increase the interval between cleaning, then it means that you are going to have to put more pumping power in order to achieve the required flux, the required flow rate through the membrane, because now it is partially clogged. So you have to balance between cleaning the membrane and the power that you are going to use in order to pump the fluid through the membrane. So if you need lesser power, if your power requirement is lower, then it means you have to clean and again and again, and it means that you are going to damage the life of the membrane. In the end, you will have a very lower longevity of the membrane, and you will have to change the membrane again and again. And if you want to use the membrane for a longer period of time, then you will have to compromise either on pressure or on flux. It means that you will have to pass water slowly because the membrane will remain partially clogged for a longer period of time, and then you will clean it after a desired period of time that you have decided in order to achieve a required longevity. So this is one of the biggest challenge. I believe that we have solved half of this challenge while working on our technology that we can talk about later. The second challenge in the membrane science, especially in water sector, is that drinking water, it has certain standards. You have to maintain certain amount of minerals in it in order to uh, meet the standards that are required, because people are, if you just give me a few minutes, I have to talk about something else in order to explain this. So we certain minerals are in our food chain that we only receive through water. And if we do not have those minerals in water, they'll start to cause mineral deficiency in our body. So if somebody is drinking demineralized water, then he is not helping himself or herself. It is going to damage their health. So the biggest example is that if somebody is having diarrhea and they lose a lot of fluid, the doctors don't ask you to drink H2O, they ask you to drink a highly mineralized water, an ORS or something like that, that can maintain your electrolyte balance. So in order to have a healthy water, you need to have at least 300 to 400, 500 mg per liter of salts in your water. The biggest challenge is in the household. Now, people who are living in the household, if they have salty water in their tap and they are going to use a reverse osmosis membrane, then that reverse osmosis membrane will extract all the minerals, almost all the minerals from the water, and the resultant water will have a lower amount of salts than that is required. And if they are using a UF membrane, then it will not remove the higher amount of salt, and they'll still have salty water. The amount of salt that is present in a tap of any household varies from household to household. So you cannot just design one membrane and you cannot give it to everybody.
I'd like to know that how PakVitae is helping the developing world in solving its water problems.
I started by working on hollow fiber membrane technology after looking at a product called Live Straw. It's a Swiss company called Westergaard, and they have a range of products under the name of Live Straw. And they have multiple products, from products that individuals can use to household products and community level products. So we started working on that in late 2013, and by the end of 2016, we had developed the hollow fiber membranes, and that were um, good enough, comparable to the live straw technology. So it took us around 2.5 or 3 years time to develop these membranes. We actually imported products of all the best companies in the world that are available and that are manufacturing hollow fiber membranes. And they all failed, and they all failed earlier than our products. So then we changed the design of the product. We started with a product where you had to backwash it after the membrane is choked using an external plunger, which you would fill with clean water. Then we changed the system, we changed the mechanism, we changed the product design in a way that whenever you open and close the filter, it will backwash itself automatically. So you do not need to backwash it. This was the first challenge that we solved. Then we again gave hundreds of modules to people on the ground, and we were working on this with the help of United Nations, UNICEF. We were working on this with the help of French government, with the help of US government, different government bodies, and we were conducting different projects here. So then this time we saw a huge increase in the longevity of membranes. The membranes never choked. People are still using those membranes, those filters, even after 3 years. But there was another problem. So we went to the field and we collected certain water samples through the filters, and we came back and we started testing those water samples, and we realized that the water was contaminated. And we were shocked because the hollow fiber membrane that we use, they filter water on the basis of size. So it's called size-based filtration. There are two methods of water filtration. So I started looking for technologies that we can incorporate in order to make our membranes antimicrobial, because I realized that people cannot clean their membranes using chemicals. All these international companies that we were following, that were our inspiration, they all failed here because they all suggested to clean their membranes using bleach or using caustic soda in water. And it took us 2.5 years to successfully incorporate antimicrobial technology in membranes. And our membranes are world's first intrinsically antimicrobial.
Making innovation happen is itself a very big task. So, what personality trait one must have in bringing innovation?
So, I was thinking about this and I realized that there are no specific traits. Anybody can innovate anything. You will see every type of innovators. You will see people who are curious, you will see people who are not curious, you will see people who have been pushed into it, you will see people who are doing it because it's fun, you will see people who are doing it because it is their lifelong goal. So you have every type of people. It doesn't depend uh, on your on your on your personality.
What is the role of exposure and mentorship in bringing innovation? How would you best describe the reason of lack of innovation culture in our society, particularly in Pakistan and among students?
Majority of students are not scientists across the globe, even if you go to uh, the best of the developed world. Majority of students will always uh, look for something to earn, look to start a livelihood. So uh, there is a very small number of people who will dedicate their life to uh, academic or research work or R&D or development of a new product, depending on their circumstances. So the main problem is not with the mentality of the majority that is same everywhere, because humans are essentially same. The main problem here in Pakistan and in underdeveloped countries is of funding and of exposure. Um, these universities, these colleges do not have money for big science competition, big science exhibitions, science fairs. They do not have industries here because, as you know, Pakistan uh, is an agricultural country. It's not an industrial country. Uh, the industrialization here is very limited. People do not even have jobs in the industries. There are many engineers uh, who have no job to do or doing odd jobs. So with and even in the industries, the R&D culture is very limited. In abroad, in the developed world, the industrialization has grown to a point where uh, all the universities have partnerships with industries because they are competing with each other. They all are looking for new products. Whenever you have to develop something new, you have to go to a university or an academia or a researcher. So you have two options. Either you can develop your own R&D team, and it is very expensive because if you are going to launch one product after 3 or 5 years, then you don't need a full-time R&D team always available in your office. You can then go to universities and you can ask them to develop something for you, give them a challenge. And you can, and these industries, they not only fund this technology development, but they also pay the students who are working for it. So the one big reason of lack of innovation in Pakistan is the industrial behavior.
You talk about empathy and innovation. Can you please elaborate this for our audience?
What is innovation? Innovation is not invention. It is not discovering something new. It is not developing something new. It is not inventing something new. That's another thing. Innovation is improving something that already exists. Now, if something is existing since a century, 100 years, people have improved it to an extent where you find it, where you don't find any mistakes in it. So in order to improve something, the first thing you need to see are the mistakes. You need to check what you can improve and how do you feel it. So empathy means that you feel the problems of people. Even if somebody has the smallest problem with the product, it doesn't mean that people have that problem. It means that this product has a margin to improve. It has a room for improvement. This is why somebody is feeling a problem. So you have to be empathetic. You have to realize the problems of people. You have to see what people feel about something. If you ignore their feelings, if you cannot feel what they feel, if you cannot empathize with their problems, if you cannot feel those problems, then you cannot improve anything. So innovation has everything to do with empathy. Those people who are okay with everything, they can adjust themselves with everything. They cannot bring improvement in a system or in a product because they don't find any problem.
Thank you, Shayan Sohail Sarwar, Chief Technology Officer of PakVitae, for your time and for moving the human story forward.